Good morning students. Last class we discussed about properties of set operations. In that we discussed commutative property and associative property. Commutative property means A union B is equal to B union A. That's a commutative property of union of a sets. Then intersection of a sets A intersection B is equal to B intersection A. Next associative property we discussed, that is A union B union C is equal to A union B union C. Only in this the brackets is difference. Like this the same intersection A intersection B intersection C is equal to A intersection B intersection C. Now we are going to see the distributive property. For any three sets A, B and C, first one is A intersection B union C is equal to A intersection B union A intersection C. That is A intersection B, this union A intersection C. This is intersection over union. Next one is A union B intersection C is equal to A union B intersection A union C. This one we call it as a union over intersection. Next we are going to see DeMorgan's law. In that first one, DeMorgan's law for set difference. So for that, in that first one, A minus B union C is equal to A minus B intersection A minus C. Next, A minus B intersection C is equal to A minus B union A minus C. Next is a DeMorgan's law for complementation. Like that, for any A and B be the, for any two sets A and B, U be the universal set. First one is A union B, the whole dash is equal to A dash intersection B dash. Next one is A intersection B, the whole dash is equal to A dash union B dash. Next exercise 1.5. First question is using the adjacent Venn diagram, find the following sets. Here a Venn diagram is given. From this Venn diagram you have to write that what are all the elements in the universal set, set A, set B, set C first. So first U is equal to means what are all the elements in this box fully, the set A, B and C, we have to write it. So minus 1, minus 2, minus 3, 0, 1, 2, 3, 4, 5, 6, 7, 8. Next set A. Set A is equal to what are all the elements in the set in the circle A. This one we have to write it as a set A. So 4, 6, 3, minus 1, minus 2. B is equal to what are all the elements in the circle BE. We have to write it as a set B. So minus 1, minus 2, 8, 7, 5. Next set C is equal to what are all the elements in the circle C. We have to write it as a set C. So 0, minus 2, minus 3, 3, 8. Now first we have to find A minus B. A minus B is equal to means, so we have to write for 4, 6, 3, minus 1, minus 2, minus, then we have to write set B. Minus 1, minus 2, 8, 7, 5. So how will we find A minus B? What are all the elements in the set A which are not in B? We have to write it as A minus B. So equal to first element 4. 4 is not in the set B, so we have to write here 4. Next element is 6. 6 is not in the element B, so we have to write 6. Next element is 3. 3 is also not in B, so we have to write 3. Next minus 1. Minus 1 is here. Next element is minus 2. Minus 2 also is the set 3. So A minus B is equal to 4, 6, 3. Next subdivision is B minus C. So how to find B minus C? First we have to write the set B. Minus 1, minus 2, 8, 7, 5, minus C. So 0, minus 2, minus 3, 3, 8. Now how will you find B minus C? What are all the elements in the B which are not in C? So we have to write it as a B minus C. So first element is minus 1. Minus 1 is not here in the set C. So we have to write minus 1. Next Next element is minus 2. Minus 2 is there in C, so we won't write that one. Next element is 8. 8 is also there in the C, so we won't write that one. Next element is 7. 7 is not in C, so we have to write 7. Next element is 5. 5 is not there, so we have to write 5. B minus C is equal to minus 1, 7, 5. And next subdivision is A dash union B dash. So for this one, first we have to find A dash. A dash is equal to U minus A. So equal to, U means universal set. So minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, minus A. The set A, minus 1, minus 2, 3, 4, 6. So U minus A means what are all the elements in the universal set U which are not in A, we have to write it as a dash. So first element is minus 3. Minus 3 is not there, so we have to write minus 3. Next element is minus 2. Minus 2 is there in A, so we won't write that one. Next element is minus 1. Minus 1 is also there. Next element is 0. 0 is not there, so we have to write 0. Next element is 1. 1 is not there in the set A, so we have to write 1. Next element is 2. 2 is not there, so we have to write 2. Next element is 3. 3 is there. Next element is 4. 4 is also there. Next element is 5. 5 is not there in the set A, so we have to write 5. Next element is 6. 6 is there in the set A, so we won't write that one. Next element is 7. 7 is not there, so we have to write 7. Next element is 8. 8 is not there, so we have to write 8. So A dash is equal to minus 3, 0, 1, 2, 5, 7, 8. Next we have to find B dash. B dash is equal to U minus B equal to minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8 minus B. That's it, B. So minus 1, minus 2, 5, 7, 8. So first, what is the first element in the set U? Minus 3. Minus 3 is not there in the B, so we have to write minus 3. Next element is minus 2. Minus 2 is not there in the set B. Is there in the in the set B, so we won't write that one. Next element is minus 1. Minus 1 is also there. Next element is 0. 0 is not there, so we have to write 0. Next element is 1. 1 is not there, so we have to write 1. Next element is 2. 2 is not there, so we have to write 2. Next element is 3. 3 is also not there, so we have to write 3. Next element is 4. 4 is also not there, so we have to write 4. Next element is 5. 5 is there, so we won't write that one. Next element is 6. 6 is not there, so we have to write 6. Next element is 7. 7 is there in the set B. Next element is 8. 8 is also there in the set B, so we won't write that 7 and 8. So B dash is equal to minus 3, 0, 1, 2, 3, 4, 6. Now we have to find A dash union B dash is equal to, first we have to write A dash minus 3, 0, 1, 2, 5, 7, 8 union B dash minus 3, 0, 1, 2, 3, 4, 6. So union means both we have to combine and we have to write it. So minus 3, 0, 1, 2, 3, 4, 5, 6, 7, 8. This is a dash union B dash. Next subdivision is we have to find A dash intersection B dash. So already in the last assembly we found that A dash and B dash. Next we will directly find A dash intersection B dash is equal to, what is your A dash? Minus 3, 0, 1, 2, 5, 7, 8 intersection B dash. B dash is minus 3, 0, 1, 2, 3, 4, 6. So intersection means we have to write only the common elements. So we have to see the common elements. Minus 3 is there in both the sets. Next first minus 3. Next 0 is there in both the sets. So 0. Next element is 1. 1 is also there, so we have to write 1. Next element is 2. 2 is also there. We have to write 2. Next element is 5. 5 is not there. So we won't write that one. 7. 7 is not there. Next element is 8. 8 is also not there. So A dash intersection B dash is equal to minus 3, 0, 1, 2. Next subdivision is A minus B union C. So first we have to find B union C. So B union C is equal to, we have to write B set first, minus 1, minus 2, 5, 7, 8, union, the set C, minus 2, minus 3, 0, 3, 8, union. B union C is equal to minus 1, minus 2, 0, 3, 5, 7, 8, minus 3. Now we have to find A minus B union C. So first we have to write A, the set A, minus 1, minus 2, 3, 4, 6, minus B union C. B union C is minus 1, minus 2, minus 3, 0, 3, 5, 7, 8. Now we have to find A minus. So what are all the elements in the A? Which are not in B. So we have a B union C. We have to write it as A minus B union C. The first element is minus 1. Minus 1 is there in the B union C. So we won't write that one. Next element is minus 2. Minus 2 is also there in the B union C. So we won't write that one. Next element is 3. 3 is also there in B union C. Next element is 4. 4 is not there, so we have to write 4. Next element is 6. 6 is not there, so we have to write 6. So A minus B union C is equal to 4, 6. The next question is K is equal to A, B, D, E, F. L is equal to B, C, D, G. M is equal to A, B, C, D, H. First we have to find K union L intersection M. So first we have to find in this L intersection M. So L intersection M is equal to B. First we have to write the set L, B, C, D, G intersection M. This A, B, C, D, H. Intersection means we have to write the common elements. What are all the common elements? B, C, D. Next we have to find K union L intersection M is equal to, first we have to write that set K, A, B, D, E, F union. Next we have to write L intersection M. L intersection M is B, C, D. Union means both we have to combine and we have to write it. So A, B, C, D, E, F. Next subdivision is K intersection L union M. So in this first we have to find L union M. L union M is equal to, first we have to write the set L, B, C, D, G union M. A, B, C, D, H. Union means we have to combine and we have to write it. So A, B, C, D, G, H. Next we have to find K intersection L union M is equal to, first we have to write that set A, B, D, E, F intersection L union M. L union M is A, B, C, D, G, H. So intersection now we have to write only the common elements. What are all the common elements? A, B, D, D. Only these three elements is, what are all the elements in the K, A, B, D. That's also there in the L union M, A, B, D. Next element is E and F. E and F is not there in the L union M. So K intersection L union M is equal to A, B, D. The next subdivision is K union L intersection K union M. So in this first we have to find K union L is equal to, first we have to write the set K, A, B, D, E, F union, the set L. Next B, C, D, G. Union means both we have to combine and we have to write it. So A, B, C, D, E, F, G. Next we have to find K union M is equal to K A, B, D, E, F union M. A, B, C, D, H. Union both we have to combine and we have to write it. So A, B, C, D, E, F, H. Now we have to find K union L intersection K union M is equal to K union L is equal to A, B, C, D, E, F, G is intersection K union M. A, B, C, D, E, F, H. So intersection we have to write only the common elements. A, what are the common elements? A, B, C, D, E, F. So K union L intersection K union M is equal to A, B, C, D, E, F. The next subdivision is K intersection L union K intersection M. In this first we have to find K intersection L. K intersection L is equal to A, B, D, E, F intersection L. B, C, D, G. Intersection we have to write the common elements. So the common elements are B and D. Next K intersection M is equal to A, B, D, E, F intersection M. A, B, C, D, H. So what are the common elements? A, B, D, D. Next we have to find K intersection L union K intersection M is equal to B, D union A, B, D. So union means we have to combine and we have to write it. So A, B, D. So K intersection L union K intersection M is equal to A, B, D. Next, first we found that K union L intersection M is equal to A, B, C, D, E, F. K intersection L union M is equal to B, D, A. Next K union L intersection K union M is equal to A, B, C, D, E, F. K intersection L union K intersection M is equal to A, B, D. Now by using this 4 we have to verify the distributive laws. What is the distributive law? It means distributive laws is equal to, by using this 4 distributive law is equal to K intersection L union M is equal to K intersection L union K intersection M. So we have to see the subdivision 2 where we have to take it as equation 1, then subdivision 4 we have to take it as equation 2. So from 1 and 2 the distributive law is, because both the sides we are getting the same elements A, B, D. K intersection L union M is equal to A, B, D. Then K intersection L union K intersection M is equal to A, B, D. Both the sides we are getting the same elements. So this both are equal. So from 1 and 2 the distributive law is verified. Next second one, next K union L intersection M is equal to K union L intersection K union M. So K union L intersection M is equal to the elements A, B, C, D, E, F. K union L intersection K union M is also equal to the elements A, B, C, D, E, F. So both the sides we are having the same elements. So here also the distributive law is verified. The next sum is if A is equal to B, C, E, G, H, B is equal to set B is equal to A, C, D, G, I, then set C is equal to A, D, E, G, H, then show that A minus B intersection C is equal to A minus B intersection A minus C. So in this first we have to take LHS side. LHS side is equal to A minus B intersection C. A minus B intersection C. So in this first we have to find B intersection C. B intersection C is equal to, first we have to write the set B. B, C, D, G, I intersection set C. A, D, E, G, H. So intersection means we have to write the common elements. There's the element A, D, G is common. So B intersection C is equal to A, D, G. Next A minus B intersection C is equal to, means first we have to write the set C. B, C, E, G, H minus A, D, G equal to. So first element is B. B is not there in the B intersection C, so we have to write the element B. Next element is C. C is also not there, so we have to write C. Next element is E. E is also not there, so we have to write E. Next element is G. G is there, so we won't write the G. Next element is H. H is not present there, so we have to write H. So A minus B intersection C is equal to B, C, E, H. So this equation we mark it as a next RHS side is equal to A minus B union A minus C. So first we have to find A minus B is equal to A, B, C, E, G, H minus A, C, D, G, I equal to, what are how will you find A minus B? What are all the elements present in the set A which are not in B? So we'll write it as A minus B. The first element is B. B is not present there, so we have to write B. Second element is C. C is present there, so we won't write that one. Next element is E. E is not present, so we have to write E. Next element is G. G is also present there, so we won't write that one. Next element is H. H is not present there, so we have to write H. A minus B is equal to B, E, H. Next we have to find A minus C is equal to A, B, C, E, G, H minus C. A, D, E, G, H is equal to, first element is B. B is not present there, so we have to write B. Next element is C. C is not present there, so we have to write C. Next element is E. E is present there in the set C. Next element is G. G is also present in set C. Next element is H. H is also present there. So A minus C is equal to B, comma C. Now we have to find A minus B union A minus C is equal to B, E, H union B, comma C. So union means both we have to combine and write it. So A union A minus B union A minus C is equal to B, C, E, H. This one I will mark it as a equation 2. So from now we found that LHS A minus B intersection C is equal to B, C, E, H. Then RHS A minus B union A minus C is equal to B, C, E, H. That one we mark as a equation 2. So from equation 1 and 2, A minus B intersection C is equal to A minus B union A minus C. The next question is verify A union B intersection C is equal to A union B intersection A union C by Venn diagram. So first take LHS side A union B intersection C. So first we have to find B intersection C. So for that one set A, set B, set C. So this is set A, set B, set C. So first we are finding B intersection C. B intersection C means the set, this is the set B, this is a set C. So B is equals intersection part, we have to shade it. So this part is an intersection part, so we have to shade this. B intersection C is B intersection C is this one. Next we have to find A union B intersection C. So A B C. So A union B intersection C. Now we have to write it A union B intersections. What are all the elements in the A and B intersection C will combine and write it. So A intersection B union C means the set A fully it will comes. Then B intersection part also it will comes. So we have to shade this A set fully. Then this intersection part also, B intersection C part also. So this is A union B intersection C. This one mark it as a equation 1. Next RHS side. First we have to find A union B. RHS side, what is that? RHS side A union B intersection A union C. So first we have to find A union B. The set A, B, C. So A union B means what we will do? A union B, na, we have to combine and write that set A and B. So we have to mark the set. This is a set A. Set B, we have to mark it, shade it fully. A union B. Next we have to find A union C. A, B, C. A union C. Now this is a set A and this is a set C. So this fully, this one fully we have to shade it. A union C. A union C. Now we have to find A union B intersection A union C. In both we have to write the intersection part. A, B, C. In this A union value, A intersection value, we have to write the intersection part. So intersection part, na, this A part is fully shaded. It is shaded here. A part fully. Then so this part is fully shaded. A part. Next this B is not shaded in this A union C. A union B, C is not shaded. Only this A part. Then this intersection part is shaded here. So A and then this intersection B intersection part is shaded. So A union B intersection A union C. This one we mark it as a equation 2. So from 1 and 2. A union B intersection C is equal to A union B intersection A union C. So this is where both the A union B, B intersection C, A union B intersection A union C both are same. So A union B is from 1 and 2. A union B, B intersection C is equal to A union B intersection A union C.